In today's little sample problem, it's a little bit more complicated because we're not going 1D anymore. We're going horizontally east-west, but also north-south. So this is a sample type of forensics problem an investigator would do. A 1,500 kilogram Geo Metro is traveling at 25 meters per second east on 55th Street, right in front of the school. Actually, I see a lot of people driving bad in front of the school. And be very careful because it's getting close to that time of month, right? But anyhow, and it collides with a 7,500 kilogram bus going south on Grant Street. And then when they crash, boom, you get an inelastic collision because basically the little Metro is going to wrap itself around the bus's bumper, and then they go flying. So the question is, with what speed and what direction do they travel just after impact? So the first thing is, let's go ahead and sketch this out in terms of what's going on. So first thing, let's orientate what's going on here. Normally on a map, which way is up? Up is what? North. Down is what? South. To the right is what? East. And to the left is west. Next, the little trick is you always want to draw two pictures. You always want to have a before picture and an after picture. And when we list our info, that's also helpful to do it in two columns, a before and after. So kind of like when we looked at energy, what was the big idea in the energy unit? In any system, the energy is always conserved. So the total energy, mechanical energy before has got to equal what? Total energy after. In this unit, what's the big idea? The total momentum in any system is what? Is also the same, right? Before and after. So in this case, we got a little tiny Geo Metro. I'll do this in the red. And it's going east. So that's going to the right, going this way. Then we have a big yellow school bus going which way? Just read carefully. The bus is traveling south. And unfortunately, the Metro driver is an idiot. He's not paying attention. And then boom, we get a big nasty crash. So using common sense, when this thing crashes together, which way is it going to move? Here's a big old bus. Here's a little Metro wrapped around the bus's bumper. Not cool. And if this thing had southward momentum and eastward momentum, what's the final wreckage going to probably do? Can you figure it out? Southeast. And probably it'll be a more southward momentum than an eastward momentum. Good. Next, let's break down the knowns and unknowns. But let's go ahead and do it. Our little trick is, in how many columns? 2 columns. So what do we know? We know the mass of the Metro, I'm going to call that M1, is 1,500 kilograms. Its velocity, let's call that V1, is 25 meters per second east. Okay, I'll just put an E in front. We know the mass of the bus is 7,500 kilograms. I'm going to zoom out a little bit. There we go. So obviously the bus has a lot more mass. Therefore, the bus probably has more what? Momentum, right? Depending on the speed, but yeah, it's going pretty fast, 20 meters per second, but it's going south. And then afterwards, they crash together, so we can combine the total mass, M1 plus M2. It's going to act as one object for an inelastic equation. So it's just 1,500 plus 7,500, so that's 85, it's like 9,000 kilograms, right? And it's going to move with some kind of final momentum afterwards. So there's some kind of final velocity. That's what we're trying to find. Make sense? We're trying to find V prime. So in an inelastic collision, here's a big idea. You have two objects moving. Step 3, we read out our equation. In an inelastic equation, the momentum before, P before, equals P after. Momentum before equals momentum after. So the momentum before is M1 V1 plus M2 V2. And then afterwards, they crash and stick, and they act as one object. M1 plus M2 times V prime, which is total. Now, why is this problem a little bit more difficult? You're like, this is easy. We just shove in a bunch of numbers. A little tricky, because the momentum is no longer linear. It's not in a straight line. They're not just both going east-west or north-south. You see what I'm saying? Let's break this down into an X and a Y direction. In the X direction, which is a car that has momentum in the X direction? Can you tell? Only the little what? The Geo Metro. So the way I could write this, okay, I'm going to write it kind of long and convoluted, just so you can see if it was a complicated problem. It would be M1 V1X plus M2 V2X, right, is equal to M1 plus M2 times V prime in the X direction. Oh, so complicated. But the bus, is it going east-west? It's not, right? It's just going north-south, so that just drops out because V2X is 0. So now it's actually not too bad because we can stick in what we know, right? M1 is 1,500 kilograms. Kilograms, if you want to be a little Canadian, eh? Just kidding. M1 is 1,500. V1 in the X direction is positive 25. Why positive? Because it's going which way? it's going east, right? Would it matter? It would, because usually we want to be consistent. We want to call going right positive. I'll do this in a different color. There we go. Left negative, going up positive, going down negative. So you're going to see the south will make it negative in a second, just to stay consistent, that's all. If you're going 25 miles an hour and another car is 25 miles an hour and you do head-on collision, it's a 50 mile per hour collision, right? You see that? So that's usually the worst kind of accident. Anyhow, let's not wish anyone any ill will there, right? And then that's equal to the combined mass, M1, M2, 9,000 times Vx prime. So right away we can solve for Vx prime. Let's just get out our calculators. Prime just means after. So we can solve for Vx prime, which is the final velocity in the x direction, by taking 1,500. Symbol doesn't matter. And then we just divide by 9,000. That's the final mass. And we get a final x velocity of 4.17 meters per second. Good enough. Vx prime is equal to positive 4.17 meters per second. What that means is we're going east. So if you think about it, that makes sense. The velocity of the little metro car, as it's going east, bam, and it slams into the bus there, it's transferred to the entire wreckage. Make sense? And notice it's less than the original speed of 25 meters per second because it's sharing its eastward momentum with a huge bus. So in other words, if you're in the bus, you get hit, you'll feel a little bit, but not as much as what the metro is going to feel.